Last day we discussed about free body diagram. I hope you understood. There we discussed about first we discussed about the net force, all the forces acting on that one, and next with the free body diagram. I just gave you two examples, a person who is walking, and the next one, if a person is riding the car, what are the forces acting on that one. And today we are going with pressure. The force which acts perpendicular in unit area is called the pressure. So when we are ready to lift an object, we are applying force on that one. When we are applying force, that means we are applying pressure on that one, and that pressure, the force which acts perpendicular in unit area is called as pressure. What is the relation between this pressure, force and area? If you are coming, pressure is equal to force by area. So the total force acting on that one and area. Then what is the unit of this pressure? The standard unit of pressure is Newton per meter square. What is the standard unit for this one? Pressure, Newton per meter square. Otherwise you can denote it as N by M square is called as the standard unit of pressure. Here the force which acts perpendicular in unit area is called as pressure, and pressure is equal to force by area. What's the relation between pressure is equal to force by area, and the standard unit of pressure is Newton per meter square. Will the pressure will act in all the directions? Means when we are talking about an object, when we are trying to lift the object, we say that the pressure will act in all the directions, but it depends on the magnitude of that particular object. The magnitude of that particular. What is this magnitude? Means the size of the object or the quantity of the object. If I am taking very small object which is of light weight, there I will apply less pressure. If I am taking a heavy object, there I have to apply more pressure. We know that. So the pressure will on an object, the pressure will act in all the directions, but you can say that there will be difference in the magnitude but not in the direction of the pressure. Why it means that depends upon the object, the weight of the object. If the weight of the object is less, means whatever force I am applying on that one will be less. If the weight of the object is more, the pressure applied by me will be more. So the pressure will be applied in all the directions. So did you understand what is pressure and what is the formula for pressure? And the standard unit of pressure is Newton per meter square. Next, area of contact. When you are coming to area of contact, so let us take two bricks, okay, of you know that how they will be in a rectangular form. They will be. Take two bricks and place them, one in a horizontal way and the other one in a vertical way. We are taking two bricks of same size, same shape and of the same weight we are taking. One you have to place in horizontal, the other one you have to place in the vertical way. Then here he is asking the force applied by you will it be different in both the cases, or will it be same in both the cases? Means here we are applying force and pressure on these two bricks. Then he is asking us to find out what is here. I mentioned for you the size, shape and weight of both the bricks are the same size and shape and also weight. So what you can understand, when I am trying to lift this two bricks, you can see that the force applied by me in these two cases will be same. The force applied by me in these two cases will be same. But what is the difference is that we can see that the area of these two objects is different. You can see that in the first case it is occupying less space, and in the second case it is occupying more space. You can see that. So if I am ready to lift a person, for example, while he was sleeping and while he was standing, the weight of the person while he was sleeping also it will be 50 kgs only. When I am trying to lift him, when he is standing, when I am trying to lift him also, his weight will be 50 kgs only. So in standing position also, if I am ready to lift that person or while he was sleeping, when I am ready to lift him, in the two cases the force applied by me will be same. Why? Because when he is standing also he is 50 kgs only, while he was sleeping also he is 50 kgs only. But the area occupied by that particular object will be different. In one case, while he was standing, he is occupying very less space, and in the second case you can see that the space occupied by him will be different. So here the force applied by us on any object will be same, but the area of contact will be changed. Did you understand? This answer is also very important. What about area of contact and force? When you are taking, you have to take these two bricks and you have to try to explain in which case it is occupying less space, in which case it is occupying more space, and how much force is applied on this one. We are going to see. The next one is the next activity is effect of force on direction of motion So when you come to this one, you can see that the effect of force. For suppose I am taking one rubber band, I am putting the rubber band in between these two fingers, I am trying to stretch that one. I can stretch this rubber band still to an extent. Still I told for you how the tension force, when I told for you what is the tension force, the string or rope to a certain distance they can move. If you are doing more, if I am giving more force to that one, what will happen? It will break in the middle. In the same way, now I took one rubber band and I am trying to stretch that one. When I stretch it, I can bring it to a certain distance. Now, second, I took one more rubber band and the two rubber bands I am trying to stretch that one. What will happen? In the first case, maybe I can bring the rubber band up to this position. In the second case, it will be reduced. What is happening? The thickness of the two rubber bands increased and the force applied by me, the pressure or force applied by me will be reduced. Now, I took three rubber bands. Means I am trying to apply more force on that one, but what is happening when the thickness of the rubber bands are going on increasing, the force applied by me is reducing, the pressure of these fingers is also, I am trying, but in the first case it took a long distance to complete it, but in the second case little reduced, in the third case, fourth case, it is what is happening whenever the thickness is increasing, the force applied by me is, so at home you try to take 3 to 4 rubber bands and you just apply on this and find the motion of this, means the movement of this rubber bands. In first case, to which extent, how much force you applied, to which, if I stretch it for a long distance, what will happen? It will cut in the middle. If 2 or 3 rubber bands are there, if I am trying to apply more force, will they cut in the middle? No, it's not happening. Why? Because the thickness is more in the second and third rubber band. Next thing is when I am riding a bicycle. When I am riding a bicycle, you can see that if the wind blows, this is a cycle when I am riding this, the wind is blowing in this direction, what will happen? I can move very smoothly. The motion of this bicycle will be free in and this air supports me. This air which is there, it supports me to move the bicycle very fast and easy. But if the wind blow is in opposite direction to this bicycle, the wind is in opposite direction, what will happen? Because of the force of the wind, here you can see that in this case, you can see that the wind stops. When it is coming in opposite direction, it makes this cycle to slow down, or totally we will come to rest position. Two things may happen. If the wind is in the same direction, when I am riding the bicycle, you can see that I can move the cycle very free and easy. But when the wind blows in opposite direction, you can see that at that particular position, I have to apply more force and pressure on that bicycle. Why? Because the wind is in opposite direction. At that moment, the force applied by me is less than the flow of the wind. What will happen means the cycle will slow down, or automatically it will come to rest position. You can see this one. When we are ready to take a ball, or what is that ball, and I am ready to kick that, what will happen? I apply force on that one, so it will move to a certain distance. I am going on applying force on that one. What will happen? When the force is increasing, the distance of the movement of the ball also will be faster. Now the children will be ready to play with the tire. When they are giving one kick, you can see it moves to a certain distance. When you are going on beating the tire, what will happen? When you are increasing the force and pressure on that one, then the object movement also will be fast. When it is moving fast, you try to keep your leg or hand on that particular object, automatically it will be stopped. What is happening? We are just ready to stop the speed of that particular object. So when they are playing football, you can see that when they are ready to kick the ball, you can see the force applied. We can see on that ball, if he is applying less force, it moves to only a certain distance. But if he is ready to apply more force, the ball will move to a long distance. And if he is going on applying the force on that particular object will be increased. You can see that. Next one more thing. What is that? Means if I am playing carrom board, for example, these all activities are given in your textbook to know about the direction, force and pressure. So when we are taking a carrom board and ready to kick the striker with the striker a coin, what will happen? You can see that there will be movement in the coin and also in on the striker. You can see this coin will move to one direction and the striker will move to the other direction. We will face two there. When we are applying less force, even the striker also will not move from that particular point. If it touches to the coin also, the coin also will not be. Means there the applied force is less. If you are ready to apply more force on that one, what will happen? To one direction the coin will go, to the other direction the striker will move, and sometimes we can see that the coin reaches to its particular position. You can find that one. So one of the example is rubber band, the other one is bicycle. You take a ball, a football, and try to kick that one and see the force applied by you. If you are applying number of times, the force will be. If you are applying more force, then the movement of the motion of the object also will be increased. If you are applying less force, then the movement of the object also will be less. Then next about the carrom board also, if you are taking the two coin and the striker, when you hit that one, we can see there is motion in both the objects. Next one is, let us see effect of force on the shape of the object. Shape of the object. So you can see here, when we are applying force on the object, what will happen to the shape of the object. So first one, if I am taking What is that? Stretching a rubber band. So here will the shape of the object will be changed means yes, first it is very small. When I am applying force on that one, it moves to a large distance. Again when I stop applying the force, it comes to its normal position. So here stretching of rubber band is a temporary change. Stretching of a rubber band is a temporary change. Next, squeezing of a bottle. Squeezing of a bottle. Already starting itself I told for you, when we squeeze the bottle, what will happen means it will change its shape. Totally when I apply force on that one and when I crush the bottle, what will happen means the shape of the bottle will be changed and it will not come to its normal position. So here we will tell it as a permanent change. Okay, next tearing of the paper. Then when we take a paper and try to tear it into pieces, again if I want to get back, is it possible? No. So it is a permanent change. Next one, squeeze a sponge. Squeezing of a sponge. Here in this case also you can see that when I crush, when the sponge was in my hand, when I apply force on this one, you can see that it was totally the shape of the sponge was changed, and when I leave it, when I just come to normal position, it has its own position. So this is also a temporary change. How can we find out that the shape of an object means some will be totally changed when we are applying force on that one, some will be, if I am taking a glass and if I throw down, what will happen? It breaks into pieces. It is a permanent change. So when we are applying force on any object, we can see that some are having temporary change and some are having a permanent change when we are applying the force. By that in that, the stretching of a rubber band, squeezing of a bottle, tearing of a paper and squeezing of a sponge. Here you can see that some are temporary changes and some are permanent changes. Next one is change in effect of force with the area of contact. When we are doing this one, for example, so you can see this for a pen, you are having the blunt side and the second one here you can see the sharp side. When I am holding this pen in my hand and I am trying to press here, when I am applying more force and when I am trying to press here, I can see that in the first case you can see that it will not pain for me. When I am applying pressure also, still I am applying. You can see that whenever we are applying force on this one, more pressure on this one, slowly you can see that here a mark will be formed and after some time it will bend. But the same pressure and force what I am applying on the blunt side, if I am trying to apply on the sharp side and if I poke here, within the first pressure itself we can see that it pains. So there is a difference between the sharp side and the blunt side. For that only we can see that when we are using a knife, we can see that the edge of the blunt one will be thick and a little bit it's not easy for us to cut the vegetables and fruits, but you can see that the sharp edge of the knife will be very easy, very thin and very sharp, easy for us to cut. So the blunt side will be thick and it will, the pressure, how much pressure you are applying on this also, it will not affect us, but to the sharp side when we are trying to apply pressure on this one, we don't need to apply more pressure. Within the short period of this, we can have the pain of this one. So this is the example for change of effect where the force in the force in contact when it is to the blunt side and when it is to the sharp side. I hope these activities are there in your textbook from activity 11, 12, 13, 14. Try to see these all examples. If you read the activities from the textbook and if you try that one and if you are having experience of that one, you will know. And why we are discussing means these all activities are very important and they will come in the exams, and tomorrow I will continue.